Hey everyone, this is Zain and I'm here back with another video of the AS Revision Challenge. So we'll continue from our last video, which was about networks, and we'll continue that. And if you want to check that out, I'm gonna put in a link in the description, as well as I'm gonna put some value over here as well. So you just can click it and go to that video. So let's continue. Okay, then we'll move on to transmission media. So we have two different types of transmission media. One is wired and the other is wireless. In wired transmission media, we'll talk about two different cables, copper cable and fiber optic cable. In copper cable, we have two further uh, possibilities. The first one is twisted pair cable, the other is coaxial cable. So twisted pair cable is a copper cable twisted together. So there are two of these cables. This is designed to cancel out electromagnetic interference. Twisted pair cable is available in several specifications. The simplest is made up of two insulated copper wires surrounded by the external insulation. One of the Ethernet networking standards uses a cable with four twisted pair, which we call Cat6 and Cat5, which supports a maximum cable segment length of 100 meters. All forms of copper wiring suffer from a loss of signal strength proportional to the cable length. The shielding screen is used either as a return path for the signal or as a form of screening to eliminate forms of electromagnetic interference. Then we move on to coaxial cable, which has a central single strength wire which is insulated from the outer multi-strand wire mesh braided around the central insulation. Coaxial cable is also available in a number of specifications. The most widely used bus networking standard for the physical layer is called the Ethernet. This is developed standards based on the transmission speed called 10 base T, which is 10 megabits per second. Then we have 100 base TX, which is 100 megabits per second, or then we have 1000 base T, which is 100 megabits per second or 1 gigabits per second. Uses of coaxial cable include connecting a radio or television receiver or sender and an aerial network, computer connections, cable television connections. So an advantage of coaxial is that the signals are unlikely to be affected by electromagnetic interference from the other metal objects in close proximity. A bus network uses either twisted pair or coaxial cabling. Then we move on to fiber optics, which is made up of 24 glass strands, which are grouped into a single fiber optic cable. Pulses of light are used to transmit a single signal along a single strand as modulated light beam. Because the medium of communication is light rather than the electric signal, the data should be free of interference. Fiber optic cable has many advantages over copper wire. The signals are free of interference. Signals do not suffer from a loss of strength. The cabling does not suffer from corrosion. Typical applications include any form of long distance communication, including telephone communication, internet communication, and networking. Then we move on to telecommunications and the electromagnetic spectrum. All forms of telecommunications include some form of electromagnetic wave acting as a single signal carrier and a form of modulation for the signal when the carrier wave is made to change to represent different signals and hence different data. If two humans communicate by talking, the carrier is a sound wave and the range of frequency is possible with a sound wave will limit the possible signals. The same is true for electromagnetic communication. Each form will have a range of frequencies which are possible with corresponding benefit and drawback which make them suited to particular applications. The first one is the radio wave. Radio waves have the largest range of wavelength and include AM around 400 meters and television around 40 meters and FM radio around 4 meters. Radio has 3 kilohertz to 3 gigahertz frequency. Radio waves are used for domestic antenna receiving television signals sent from the TV broadcaster radio, and it's also used for sending and receiving of mobile phone communications. Then we have microwaves. Microwaves have wavelength measured in centimeters. Unlike infrared and visible light, microwaves can penetrate haze, light rain, and snow, and sometimes cloud and smoke. For this reason, satellites which capture pictures of Earth use microwave communication. Then we have infrared. So infrared waves occupy the range of wavelength between microwaves and visible light. The range of wavelengths varies from the size of a pinhead to the size of a cell. They are measured in a unit called micron, which is 1 millionth of a meter. The shorter infrared ranges are the wavelength used for remote control signals between a controller and a device such as television. Artificial satellites orbiting the Earth provide telecommunications between the satellite and receiving and sending stations. Applications are numerous and varied. Satellite radio and television broadcasting, photographing of the Earth, satellite based internet, satellite phones, military communications. So now let's move on to bit streaming. Any reference to streaming media would normally imply that bit streaming is used. So there are two categories. For one category of streaming media, the source is a website that has the media already stored. One option is, in this case, is for the user to download a file, then listen to it or watch it later some point in time. However, the users do not wish to wait that long. There is the streaming option. The option is described as viewing or listening on demand. In this case, the delivery of the media and the playing of the media are two separate processes. The incoming media's data are received in a buffer created on the user's computer. The user's machine has media player software that takes the media data from the buffer and plays it. For example, YouTube or Netflix. The other category is real time or live transmission. In this case, the content is being generated as it is being delivered, such as when viewing a sporting event. At the receiver and the technology is the same as before. The major problem is at the delivery because a very large number of users need to watch simultaneously. The way forward now is to transmit the media initially to a large number of content providers, which then transmit onwards to individual users, as we see in Facebook live stream and YouTube live stream. Then we'll move on to IP addressing. Using the Internet Protocol IP, networks are joined into a network of networks through interconnected gateways or routers that use a standard protocol suite. TCP/IP, Transmission Control Protocol, Internet Protocol for internet networking. Most internet traffic is still using Internet Protocol version 4 for addresses. This uses 32 bits or 4 bytes for an IP address, expressed as four numbers in the range of 0 to 255 separated by full stop. An example for which could be 192.168.0.1, which is usually your router IP. The original addressing for networks are used the first byte for network ID and the other bytes for the host identifier. This quickly proved inadequate and led to a system of defined classes, where a variable number of bits is used for network identifier. The system defined five classes: A, B, C, D, and E. Classes A, B, and C are different bit lengths for network identification. The class formats impose some restrictions on the available addresses. For example, a class C address is not allowed to host 0 to is not allowed to use host number 0 to 255. Internet traffic has no dedicated path. There is no single interconnection point or fixed network hierarchy. as used by the PSCN. Individual data packets may take different routes over separate networks as they travel to their final destination to be reassembled and delivered to the requesting computer and application program. This is unlike circuit switching, which relies on physical point to point connections. On the internet, data is placed in packets with an IP address for the packet's destination and an IP source address. An IP address is a 4-byte number usually written in denary. For example, 192.168.0.1. This is called the dotted decimal notation. The address can also be written as dotted hexadecimal or dotted binary, which you can convert from denary. So these bits that I have assigned in network also includes the class identifier. So this is 0, which is part of the 8 bits that are in net ID. So these are 7 separately and 0. And this is 14 and 10. And this is 110 and 18. In 2011, the IP version 4 address final space was finally exhausted. All 4 billion version 4 IP addresses had been allocated. However, the ever increasing number of internet users had given concerns about address space exhaustion earlier. This gave rise to a new standard, Internet Protocol version 6 or IPv6, which was adopted for the first time in 2006. IPv6 increases the address length to 128 bits, providing a vastly greater address space. The immediate issue is that the host devices which only recognize IPv4 addresses cannot directly communicate with IPv6 only hosts. Migration to IPv6 is in progress, but completion is expected to take some considerable time. Then we'll move on and see what domain name service is. A browser requests a resource using the known URI. What is usually not known by the user is the matching IP address for this resource. Therefore, somewhere on the internet, the IP address must be looked up for the URL. This is the role of the domain name service, DNS. Once the IP address is known, it is the function of hardware called routers to route the data packets to the receiving device. Because maintaining a central list of domain names and IP addresses mapping would be impractical, the list of domain names and IP addresses are distributed throughout the internet in a hierarchy of authority. The domain name service database resides on a hierarchy of special database servers. At the top level of the hierarchy, root servers store a complete database of internet domain names and their corresponding IP addresses. The internet employs 13 root servers that have somewhat famous for their special role, maintained by various independent agencies. These servers are empty named A, B, C, D, and so on to M. 10 of these servers are sited in the United States, one in Japan, one in London, and one in Stockholm. Most lower level DNS servers are owned by businesses or ISPs. For example, Google maintains various DNS servers around the world for management of google.com, google.co.uk, google.com.pk, and other Google domains. Your ISP also maintains DNS servers as part of your internet connection setup. There is probably a DNS server within close geographic proximity to your access provider that maps the domain name used in your internet request or forwards them to the other servers in the internet. When a client browser requests a resource from with a URI, a piece of software called DNS resolver is usually used to build that is built into the network operating system. First contacts a domain name server to determine the server's IP address. If the DNS does not contain the mapping, it will forward the request to a different DNS server at the higher level in the hierarchy. So this then becomes the ISP's DNS resolver, and this goes on until it reaches the root. An IP address can be thought of as a private or public IP address. Any device on the local area network will have a private or non-routable IP address located by the network administrator. This is sufficient if the only communication is between host devices or the local area network LAN. If, however, a computer needs to access a resource using the internet, the device needs to know the public address of the server holding the resource. Every resource on the internet must be known globally and a unique IP have a unique IP address. As there is a shortage of IPv4 addresses, devices on the local area network are allocated a private IP address. The three ranges used for private addresses are 10.0.0.0/8, 172.16.0.0/16 to 172.31.0.0/16, and the most commonly used 192.168.0.0/24 to 192.168.255.0/24. This will be a requirement for any of the devices on the local area network. They will communicate to the internet through the proxy server and firewall, which has a single public IP address. All data packets whose destination is a device on the local area network will arrive on the local area network's public IP address. It is then the role of the proxy server to route the data to the appropriate device. This ends two of our topics that we had discussed today: networks, that we continued from yesterday's class, and IP addresses. Tomorrow we'll continue with the same chapter, but we'll do a different topic, that is client and server side scripting. That will end our chapter 2. So this is it for today. See you guys tomorrow. Hope you liked the video. If you liked it, please like and share it with your friends, and subscribe to my channel so you can get the chance to look at it as it is released. See you guys.
Hold up.